So here's example 8 with the chain rule. F of x equals natural log of this huge mess here, 3x to the 5th divided by x plus 1 to the 9th times tangent of 4x. Okay? So remember, chain rule says if you want to take the derivative, so that's what we want to do here, we want to find f prime of x. So the derivative of the natural log of a thing is 1 over that thing times the derivative of that thing. Okay, in this case, that thing is 3x to the 5th over x plus 1 to the 9th times tangent of 4x. And I don't know about you guys, but I do not want to find the derivative of that. No way. No. So what can we do instead? Is there something else we can do instead? Yeah, luckily there is. So before we move on to, or before we jump right into the derivative, let's go ahead and simplify this. So what's great about logarithms is you could have a really complicated expression in there, like we do here, but then you could use properties of logs to make this not so bad. So let's go ahead and do that. Remember, one of the properties of log says natural log of a over b, like that, equals natural log of a minus natural log of b. Okay. So in other words, natural log of something divided by something else equals natural log of the top minus natural log of the bottom. All right. So let's go ahead and use that property. So this is going to equal natural log of 3x to the 5th. All right, put parentheses there, not really necessary, but good to have, minus natural log of the bottom. This is x plus 1 to the 9th times tangent of 4x, like that. Okay? So already this is a little bit simpler here, right? That's good. So now we're going to want to use the fact that natural log of a product, we've actually used this fact once before in one of the other videos, I think. Natural log of a product is natural log of the first thing plus natural log of the second thing. Okay? So here we have natural log of 3 times x to the 5th. Okay, that's 3 times x to the 5th, right? So this is going to equal natural log of 3 plus natural log of x to the 5th. Okay? And then what happens over here? Well, here we have natural log of x plus 1 to the 9th times the tangent of 4x. Okay, so natural log of a product, split it up as a sum of 2 logs. So x plus 1 to the 9th, and then we'll do this here, and then plus natural log of tangent of 4x. Okay? Now we want to be very, very, very careful here. Okay, natural log of x plus 1 to the 9th times tangent of 4x equals natural log of x plus 1 to the 9th plus natural log of tangent of 4x. But we have a minus sign in front of it, so we want to be very, very, very careful with our parentheses, and this minus sign here affects everything. Okay, so we got to have these big old parentheses that I just put over here. We got to have those there. Okay, because again, natural log of this mess is natural log of that plus natural log of that. Okay, so if we put a minus sign in front of it, then we got to make sure that the minus sign is still in front of everything here. Right? So that's what we have so far. So now let's go ahead and we're going to use one more property, and that property is natural log of x to the r, okay, like that, equals r natural log of x. So remember, if you have an exponent inside of a log, it can come out as a factor like that. So now we're going to use that property. So this is going to be natural log of 3 plus 5 times the natural log of x. Alright, and then let's go ahead and also distribute this minus sign. So this, if we drop the parentheses here and here, then minus sign gets distributed, this plus becomes a minus. That's pretty much all that changes. And then what happens here? The 9 in the exponent comes out as a factor. Minus 9 times natural log of x plus 1. And then minus natural log of tangent of 4x. Okay? So there's nothing we can do to simplify this last one. We're just kind of stuck with it. You know, 4x, yeah, that's a product, right? But it's stuck inside of the tangent. So we can't split it up with any log properties because the tangent there is kind of ruining that for us. But, oh well. Okay, so this is f of x, right? So just to recap real quick, we started with f of x equals this mess here, and then we used properties of logs to expand it to get this, then we use another property of logs to get this, and then we use another property of logs to get this. So let's zoom out a little bit just to see everything here. This, what we started with, was a huge mess, and taking a derivative of that would have been an epic disaster, which we just, we definitely want to avoid that. But here, this really isn't that bad, right? So we've simplified it down to this. This isn't so bad. So let's go ahead and do the derivative of that. So if f of x is this stuff here, then f prime of x is what? Well, ln3, that's just a constant, right? So the derivative of that is 0. So that's good. Now what happens over here? Plus 5 times what? Derivative of natural log of x is 1 over x. Alright, that's good. Now what happens here? Minus 9. Okay, remember, constants can be pulled out of derivatives. So that's why all these constants here stay. Oh, and also, I don't know if I mentioned it explicitly, we've done it several times before, but we're just differentiating term by term. So if you have a bunch of stuff being added or subtracted, you could just do one term at a time. So just do this term first, its derivative is 0, then do this term, the constant comes out, so we still have the 5 there, and then derivative of the natural log of x is 1 over x. Now we move on to the third term, minus 9, okay, it's just a constant, so it can be pulled out of the derivative, so we still have the minus 9 there, and now we have natural log of a thing, okay? Derivative of natural log of a thing is 1 over that thing, times the derivative of that thing. That thing is x plus 1. What's the derivative of x plus 1? It's just 1, right? So nothing really too interesting happening there. So we do technically, we are applying the chain rule, right? It is working behind the scenes, but the chain rule just tells us we have to multiply by 1 in this case. So that's all that's happening there. Now the last term, this is a little more interesting with the chain rule, okay? Something's actually happening here. So natural log of a thing is going to be, if you want to take a derivative, that's going to be 1 over that thing, okay, 1 over tangent of 4x times the derivative of that thing, all right? And what's the derivative of tangent of x? All right, well, let's go ahead and actually write it like this, times d dx of tangent of 4x, all right? So we have to use a chain rule again, actually, right? So here's x multiplied by 4, all right? And then we take a tangent of it. So tangent of 4x, if we want to take a derivative of that, the big guy is tangent, right? So that's the that's the outside thing. First you multiply x by 4, and then you take a tangent of that. So the big guy is tangent because that's on the outside. It's affecting everything, or it's affecting the 4x, which in this particular factor is everything. But anyway, so the derivative of that, derivative of the big guy is secant squared, right? So if we just have tangent of x, the derivative of that is going to be secant squared of x. But remember, the chain rule says derivative of the big guy evaluated at the little guy. So the derivative of tangent of 4x is going to be the derivative of the big guy evaluated at the little guy, and then times the derivative of the little guy. Okay, now the little guy is 4x, so the derivative is 4. Alright, so that's, this all came from this term here. So we applied the chain rule twice, actually. Okay, so natural log of a thing, the derivative is 1 over that thing times the derivative of that thing. And when we did the derivative of that thing, we had to do the chain rule again. Alright, so that's what happened there. Now let's go ahead and simplify. Not really much to simplify, but we can just clean it up a little bit. So we're out of room over here. I guess we'll just erase this. So if we come back up here, then we can say f prime of x. Let's use a different color for no apparent reason. So f prime of x equals 0 plus, so we'll just say this is 5 over x, and then minus 9 over x plus 1. And then minus 4 secant squared of 4x over tangent 4x. So minus 4 secant squared of 4x over tangent of 4x. Not sure why I pushed this so far over. But anyway, that's our derivative here. All right. Okay, so let's just go ahead and recap this real quick. we started with this mess here, and we remember that the derivative of natural log of a thing is 1 over that thing times the derivative of that thing. But you know, doing that on this, epic disaster, don't want to do it. It'll work, you know, if everything works out okay, you'll get the right answer. But you know, to take the derivative of this on the inside, you got to do the quotient rule, and doing the quotient rule on that is just, no, it's going to be terrible. You will get the same answer. It probably won't look anything like this, but it will be the same thing. Okay. But anyway, well, the better idea is to use properties of logs to expand this, and you know, that's what we did here. Okay. And then we eventually got down to this, and then we just differentiated term by term, which is so much easier than taking the derivative of this, I guarantee you. So we differentiated term by term, then we got 0, 5 times 1 over x, etc., etc., etc. And then that's simplified and cleaned up to this. And that's example 8 with the chain rule.